Hi guys, from today onwards we are going to start solving non-linear data structure. So far in our blind solve series we will be solving arrays, queues, linked lists, kind of patterns, non-linear linear data structures. So from this video onwards we'll start solving the non-linear one like trees, graph, kind of things. So without wasting much time, let's get into the first problem. So today problem is all about binary tree. So we'll start with the binary tree and we'll see explore all different nonlinear data structure in blind 75 series. So the first problem is inverted binary tree. So what do I mean by inverting? So inverting is nothing but process of converting a left tree to a right tree. So let me explain very clearly. You can see the roots are pretty much same, but what do you see on left side? Now it is on the right in an inverted tree. Am I right? So right now, let's say this is the original tree. In original tree, 2 is on the left side, but in a inverted tree, it's on the right side. How you understand what is inverting? It's nothing but what is on the left becomes right, what is on the right becomes a left. It's going to apply in every single step as well. If you take this particular tree, again we apply the same logic. What is on the left become right, what is on the right become a left. So we just interchange the node. So this will come here and this will go here, which means 9 is here, 6 is here. Again you will apply the logic in this particular subtree as well. So 3 will come here, 1 will come here. You can look at this particular tree. This is the inverted one. So if you don't understand, again you can assume there's a mirror here. So this problem can be called as a mirror of a tree or a flipped tree. So all the meaning is nothing but what is on the left we should become a right. So what is our initial approach is going to be, guys? So we need to find the which traversing algorithm to choose for this case. It's very important to choosing the traversing algorithm in all the binary tree problem. And now let's think about what are the different traversing algorithm we do have. So we do have BFS, DFS, we do have BFS, breadth first search, and then we do have in-order traversal, pre-order, and post-order. We have this many traversing algorithm. So how to choose this? For this particular problem, if you look at, we are going level wise. We're just going this level, we're just interchanging it. Again, we're just going this, we're just interchanging this. We are going here and interchanging it. So you can typically solve with BFS very easily, and as well as you can use DFS, which is kind of recursion. We talked about this tree, this tree, this tree, right? So this comes under DFS solution, but if we go level wise, it comes under BFS solution. So we'll talk about both the solution. So I have discussed both the one in the problem explanation. As I said that this subtree also we have to do, this subtree also we have to do, and at finally we'll do the entire tree. So if you do this process, recursion process, you will end up in this particular tree. Again, you can apply BFS as well. So I will explain both the thing. First, let's talk about DFS because DFS is a bit difficult. But if you understand DFS, BFS is pretty much easy. So now let's see how to apply BFS. Now you understand what's inverting. So basically what we are doing is we are just interchanging the point. So what's on the left become right, what's on the right become left. That's what we're doing it, right? So we're just doing it in every single step. If you take this particular step, so left pointer is going to be this side and right is going to come this side. Again, we're just doing the same process, right? We're just doing this particular thing only. How to do this? Very simple. The first step what we need to do is we need to check the node is valid or not. If it's a valid node, we can proceed further. Applying this particular algorithm. If it doesn't, we can simply return none. So if root is equal to null, then you can simply return null. And next step, what we have to do? We need to apply the recursive algorithm, right? So now what's the step? We need to invert left to right, right to left. So now let's interchange it. So before that, let's store a temp. Temp is going to be root dot left. And now root dot left becomes root dot right, which means we are just taking out this particular link, this left link, and we are just making it to the right position, right? Now what we have to do, we need to make this connection as well, the right connection to the left. So root dot right is going to be temp. That's it, very simple. Now we just interchange the things. Now what do we have to do? We need to solve for a sub problem as well. Sub problem is nothing but this kind of things. Again, we need to repeat this process. For that what we can do is simply call the function. So let's name this function as invert. Invert is going to have a root and it's going to return a root as well. So what we can do is very simple. So invert is root dot left and invert of again root dot right. At last you can simply return a root. That's it. It's very simple, right? But the one crazy thing about recursion is it's very hard to understand initially, but once you start understanding DFS, all the algorithm is going to be pretty easy and pretty small as well. Now what we are doing is at the first step we just interchange this particular node. Now what we are doing, we are just calling the same function to solve this particular problem. For the left tree we are telling it to solve. So again this will go to the call stack and now this is going to be our pointer. Now this is going to be our pointer if you remember. Okay, let me draw out the call stack. So initially it will start from 4, right? So initially we'll start from the 4 and from the call stack we'll just take it out 4. Now we are just doing interchange this position. After interchanging, what we are doing is we are telling it to solve for the left sub problem and right sub problem as well. You can see we are calling for left, right as well. Now 2 will be on the stack and 7 will be on the 2 will be on the stack. So the left subtree. Now the node will be pointing to this particular place. Now what do we have to do? The same process again, just swap the nodes. This particular place, just swap them. So we'll swap this thing out. Now left will become a right and then right will become a left. Again, we'll do for right subtree. 1 will put a stack. 2 will go. If you take for a 1, we already reached the leaf node. So there is nothing going to be there. So 1 will be go. Now 3 will come into the call stack. This root dot right will come. Again, this is already the leaf node. So there is no interchange possible. So this also will come out and this will return this inverted tree. Now we need to solve the similar thing for a right subtree. So right subtree will be on the call stack. 7 will be there. Now again the same typical process. So what is on the right become a left, what's on the left becomes a right. Very simple. Now again we just return a root of a tree. I hope you guys understand this particular problem and we have written a pseudocode as well. This is the entire code. It's very simple and easy as well. And now let's talk about the DFS solution. DFS we will do level ordered reversal, but in a DFS we will go left, right, root. This is the order of the DFS one. It is a recursive nature, but BFS is iterative in nature. We'll just go level by level. For that we are going to use queue data structure. So initially we'll just put the root in the queue. What we'll do is we just pop this node. We're just popping the node. We're just going to apply the same logic. We're just swap the nodes. So initially we'll have the root node and we just pop it out. And what we'll do is we'll just swap it. Similarly, what is on the left will become a right. What's on the right will become left. The same piece of code we'll just do here. So it will look 7 and 2. Now what we'll do is we just push the left node, right node. If you remember carefully, we need to do this level wise. Right now we just finished this particular level. Now we need to go for this level also, right? So what we'll do is we just push the element to the queues. Now let's push 2 and let's push 7 as well. Now we just pop the node 2 from the queue and we'll just do the particular operation. What do you have to do? Take the left and right node, swap them. So if we swap, it will look like this, 3 and 1. Now again we have to put things in a queue, right? So put 3 as well as the 1 in a queue, and next we have to pop node 7 and do the same approach. We're just going to interchange the left and right. So if we do that, it will look like this. 9 will come here and 6 will come here. Don't forget to put this in a queue. 9, 6. Now what you have to do, take a 3. Now if you look at a 3, there is no nodes left to do because it's already a leaf node. There is no change going to come, so we won't do anything. Again, 1 is also same, it's a leaf node. 9 is also leaf, 6 is also leaf. So we don't want to do any particular thing. What if we have 10 over here? What to do at particular at this point? Whenever we just popping this node, what we are doing, we're just inverting the nodes, right? So right now 10 is on the right side, so we have to just make it on the left side. That's it. Pretty simple. And we'll add the 10 and the 10 to the queue, and we just see 6 is a leaf node. We won't do anything. Again, when you come to 10 is also leaf node, we won't do anything. And at last we just end up returning the entire root as well. If you look at a root is already inverted one. And I hope you guys understand this particular algorithm, the both BFS and DFS. Now let's code this up. I'm going to code BFS. Sorry, I'm going to code DFS. BFS is pretty simple. You can do it on yourself. What is the first step in the algorithm, guys? The first step is we need to check if the root is valid or not. The reason because you can see the constraint, the number of node in the tree can be 0 to 100. So if the root is empty, we just need to return a null. That's what is given in a question. So we just check if root is none. If it none, simply return empty. I mean none as a result. If it doesn't, what do you have to do? You have to interchange the values, right? So in Python, I can do simply like this. So root dot left comma root dot right is equal to root dot right comma root dot left. If you are using some other language, you will have the temporary and you just swap it out and use the temporary for the right one. I think I have showed in my pseudocode. You can follow those approach, but if you're using Python, you can do this very simply. And after interchanging it, what you're doing, we're just calling the invert tree function. So invert tree. So what's our node is going to be left node, root dot left, and the same code for we'll call the same function for right node as well. And after all these things, we just need to return root. That's it. Very simple, right? So what is this self is nothing but this is how we have to call the function in a class. So we have to use the self keyword to call a function. This is just Python stuff. You don't need to worry about it. The basic idea is just swap the nodes and do solve for the subproblem as well. Subproblem will also do the same thing. We'll go to this particular subproblem, subtree, and we just swap the node. Again, just go to the another subtree, swap the node, and do the process until the complete tree is done. That's it. Very simple. Now let's run this and see. Yeah, it passed the test case. I hope it will pass all the test case as well. Now let's see. Yeah, it does. You can see it is the optimal solution for this particular problem. I hope you guys understand this particular solution and my explanation as well. Thanks for watching till this year, and we'll meet again in one more video. Until then, bye.